Welcome back, guys. And today we are going to be hitting a little bit of review. For some of you, this may kind of seem like, why are we doing this? But I think a lot of us are on different pages. And so I think it'll be really helpful to actually go back and review these things. So today we're going to be adding and subtracting polynomials or just combining like terms. And even if everyone is like, oh, I know how to do this, I think we really just need to solidify this because a lot of people are still messing this up in what we were doing right now. So for our think slash warm up, I have write out what 2 times 3 squared plus 3 times 3 squared is in terms of addition, then write it as one term. So when I say write it as addition, so what is 2 times 3 squared mean? 2 times 3 squared really means, well, let's take 3 squared and let's add it again, right? 3 squared 2 times is what it means. Or you could do 2 3 squared times, but I think it's nicer for us to say 3 squared twice, which is 3 squared plus 3 squared. And then, again, order of operations, so I have to do this multiplication first. So I have plus that plus, and then 3 squared 3 times is what that means. So 3 squared 3 times. And when I say write it as one term, what we really have now is we have 5 3 squareds, right? We have 5 times 3 squared here. So 5 times 3 squared. And we're going to extend this to variables. Imagine if this 3 was an x instead, right? Then we'd have 2 times x squared, or often we just write the x squared right after. And then we have plus 3 times, and then if we replace 3 with an x, times x squared, we would normally just write it right after. And we would see that that would be 5, 2 plus 3, x squared, just like this was 5 times 3 squared. This would be 5 times x squared. And the whole goal of today is that you can only combine these 2 plus 3 if you have x squared, right? If we had 2x plus 3x squared, we wouldn't be able to combine them because this wouldn't happen over here, right? We would just have 3 plus 3, which is 6, and then plus all these 3 squareds, which is something totally different. So we just have to leave these separate when we're talking variables. And so like terms are terms whose variables and their exponents are the same. So for example, in this expression, 3x squared minus 5x minus 8x squared plus 9 minus 2x, a lot of words, right? 3x squared and negative 8x squared are like terms since they both have an x squared, right? That's whose variables, so they both have an x, and exponents are the same. They both have x squared, right? Are there any other like terms? There sure are. If we look up here, we have a negative 5x and a negative 2x. Those both have the same variable with the same power. There's an invisible to the first, right? To the first. So negative 5x and negative 2x sure are one. And then also one that we might not, or I guess that's all we have there. But let's say, for example, maybe we had a minus 3 on here, then 9 and negative 3 would also be considered like terms, right? Because they both have the same variable, which is no variable, right? It would actually probably just be considered simplifying, but technically they are like terms. They're both constants. So we can only combine like terms. So for example, we can't combine 3x squared minus 5x in any way since they're not like terms, right? Because this is x squared and this is x. So even if they're the same variable, if they have different exponents, we can't combine them in any way whatsoever, for the reasons kind of previously stated. But for example, we can combine 4x minus 9x since they are like terms, right? Since they have the same variable x and they're both to the same power, which is an invisible 1. And so when we do this, all we do is add and subtract the numbers and leave the variable, right? We have 4x minus 9x. How I like to say it is we have 4 of something, and then we subtract 9 of that same something. So how much is left? And the answer would be -5 of that something. But when I say that something, I'm talking about x, right? And if it helps you, you can talk about money. Replace x with the word like dollars. So if you have $4, right? If you have $4, and then you want to buy something worth $9, you can't do that, right? Without owing -$5, right? So just replace dollars with x here, right? If you have 4 of something and you take away 9 of something, right? A lot of people will still get confused with their negatives, and adding negative numbers or subtracting and working with negative numbers, right? Or you could also just do 9 minus 4, which is 5, but then you realize that the -9 is bigger, so that means it has to be -5. And then that x just stays out front, right? If we have 4 of this, subtract 9 of that, then we're going to have -5 of that same thing. So for example 1, I have combined like terms. So to do these look pretty long, but they're not that bad. So the first thing I'm going to go do is I'm going to just pick out all my like terms. I have a constant here, a constant 2. Do I have any other constants? I have a constant 5, and I think that's it for constants. So I have a +2 and a +5. Let me switch colors here. Now I'm looking for anything with a y. I have a -4y. We have to include this negative, right? So there's a y. That's y squared. That's y squared. Oh, there's a y and there's a y. So let's put all those together. We have -4y plus 4y minus 2y. Let's do one more color. And now, okay, now I see y squared. So I have -7y squared. Oh, there's another y squared. And that looks like everything, right? So let's do this. -7y squared plus 5y squared. And now we kind of have everything nicely together. If you want to, you could put parentheses around these so that it makes even more sense. But now we can just go through each of these. 2 plus 5 is 7. And then -4y plus 4y, that's going to be 0y, right? Minus 2y, 0 minus 2y is going to be just minus 2y. And then we have -7y squared plus 5y squared. And -7 plus 5 is going to be -2. And then that y squared hangs out front. And then I just like to write it in descending order because we usually like to have our y squared term first, the highest power first, and then minus 2y, and then this is a +7, right? So I just like to write it in the end like that. All is one with the highest power in front and then descending in order. So, and take note here, right? We only combined things that had the same variable and exponent. We only combined the 4y, this 4y, and this 2y because they have the same variable and their exponents are the same, an invisible 1. And then same here, we only combined the y squareds because they're the same variable with the same exponent, right? A lot of people still want to combine, y squareds and y's, but we can't do that. So one more example. Again, I'm just going to go through and start going to start with -1. Do I see any other constants? I have a -6. I have a +5, right? Those are all the things without a variable. So let's just write these out. We have -1, -6, +5. And I'm just rewriting the order, right? You can add and subtract in any order, right? 3 minus 4 is the same thing as -4 plus 3. So we can add in any order. Now the next thing I see is a 4x cubed, and that's a y. And there's a 6x cubed and a -4x cubed. Okay, so let's write those out. The first one I had was a positive 4x cubed, and then I had a positive 6x cubed, and then a minus 4x cubed. Now let's keep going because we don't have everything. Our next term, we have a 7y squared, but that's actually everything, right? That 7y squared is just kind of by itself. Now we have, let me put equals -1 minus 6 is going to be -7 plus 5 is going to be -2. 4x cubed plus 6x cubed is going to be 4 plus 6 is 10x cubed minus 4x cubed is going to bring us back down to positive 6x cubed. Sorry, positive 6x cubed. And then lastly, just because that 7x doesn't have anything to combine stuff with doesn't mean it just goes away. So, or I said 7x, but so we just need to add that on, that 7y squared, we just need to add that on. And again, I just like to have my highest power first. It's not going to matter what order you write it in. And then I like to put any variables first here, -2. You could write it in any order you would like. You just need to make sure you keep all your signs the same. So that would be combining all the like terms for that one. Now, if we had another one where we had another y squared in here, we'd have to combine that here, but we didn't. So just one more example. We have an a and a b. I want you guys to be careful here because as soon as we see parentheses in these things, we're used to like multiplying in between these, but this isn't multiplication, is it? We're just adding, right? So let's think about this. These parentheses really don't mean anything. It means this whole chunk plus this whole chunk. So these beginning parentheses don't really mean anything. So I'm just going to rewrite it without parentheses. 2x squared minus 2x plus 1. And when I say plus this whole thing, well, we can just kind of get rid of those parentheses. Plus a -8x squared really just means -8x squared. Plus a -7 really just means -7. Right? Now we can combine our like terms. I see a -2x squared. Oh, and here's another x squared term. And that's all of those. So now we have a -2x. Do we have any other x's? It doesn't look like we do. So let's move on. And then we have a +1 and a -7. Good. So now let's combine these. We have -2x squared minus 8x squared. Our red is -2x plus 1 minus 7. All right, we're combining like terms. We have the x squared, -2 minus 8 is going to be -10x squared. A lot of people are still messing these up, right? If I owe someone $2 and I borrow $8 more, I should have -$10. That -2x again is all alone. And 1 minus 7 is going to be minus 6. And again, I just like to rewrite them as, or it's already kind of in order, but I'm going to write it in black so that we know we are all done. All right. One last example. So we're going to have equals. Again, this first parentheses kind of just means nothing, so I'm just going to take it away, right? 4x squared plus x. Now, when I say minus this whole thing, right, I have to kind of distribute that negative, right? So minus this whole chunk really means, what is minus negative 8x squared? And minus a negative really means a positive, right? So plus 8x squared. And then minus a negative again really means plus. And then minus a positive really means minus. And now again, we can go through. I see negative 4x squared plus 8x squared. Those are only x squared terms. We have positive x and plus 2x there. And then here, the negative 6 is just all by itself. So what we really have is negative 4x squared. Let's put these together. Plus 8x squared plus x plus 2x. And then minus 6. Now combining these, 4x squared plus 8x squared, negative 4 plus 8 is going to be positive 4. Then that x squared hangs out front. And x plus 2x, this is really an invisible 1 in front of here. So 1 plus 2 is 3x. And then that minus 6 is just all by itself. And we are done, right? And I'm just going to rewrite it in black so you can see that that is our final answer. So again, this is probably a review, and going over this, most of you are probably like, oh yes, I know how to do this. And even though all of you may know what to do, I think it was just really good to go over because of a lot of us, it's not just a few, a lot of us are still just messing up combining these things. So hopefully this was a worthwhile review for you guys.